Following is an excerpt taken from the third of 3 sessions that make up the 7-hour-long Module 5 training course on process piping design. Following is a discussion on the various types of corrosion. This brief excerpt discusses the meaning and application of corrosion allowance for pipe wall. The term corrosion allowance is actually a safety factor that is applied to the pipe wall in calculating pipe wall material thickness. Key considerations in allowing for corrosion are fluid compatibility with the pipe material. This is where fluid service and pipe material compatibility are determined. Fluid design temperature has a direct correlation with the compatibility of the fluid surface with a pipe material. Potential for fluid surface conditions to deviate from norm. Potential deviation in the pH of a fluid or wide swings in a fluid temperature can have a marked change in the compatibility of fluid and pipe material. A rule of thumb for non-aggressive fluids such as cooling tower water, chilled water, etc. in carbon steel is to assume 1 mil or 1/1000th of an inch per year of general corrosion. Applying that to a 20-year service life, it would work out to a material loss of 0.02 inches, meaning that you should expect a minimum general material loss of 0.02 inches over the life cycle of the piping system. This does not account for unanticipated corrosion anomalies such as pitting, high temperature hydrogen attack, microbiologically influenced corrosion, and others. And corrosion seldom occurs evenly throughout a system. The areas most susceptible to a higher than normal rate of corrosion will be at directional changes such as T's and elbows. Corrosion allowance typically applied to carbon steel is 0.05 inches. Corrosion allowance typically applied to stainless steel is anywhere from 0.0 to 0.03 inches. Example calculation to determine the pipe maximum allowable working pressure or pressure rating. Using 6-inch nominal pipe size A53 grade B ERW carbon steel pipe schedule 40. The schedule 40 has a wall thickness equal to 0.28 inches. The next step is to deduct mechanical allowances from the wall thickness. Deduct the corrosion allowance typically used for carbon steel, which is 0.05 inches. Deduct manufacturer's wall thickness tolerance. It states under ASTM A53 that the minimum wall thickness at any point shall be not more than 12% under the nominal wall thickness specified. That would therefore be a deduction of 0.035 inches. Adding those up, you have a total of 0.085 inches of deductions from the wall thickness. Taking the wall thickness of 0.28 inches minus the 0.085 deduction leaves you a wall thickness of 0.195 for the calculation. The burst pressure can then be calculated using the following equation. P equals a burst pressure, S equals minimum ultimate tensile strength, T equals pipe wall thickness, and D equals pipe OD. That would give us a burst pressure of 3,532 psi. The burst pressure is then divided by a safety factor of 4 in accordance with ASME Boiler Pressure Vessel Code Section 8, paragraph UG 101 as follows. The 3,532 psi is divided by 4, which equals 883. If you round that down to 880, that gives you your maximum allowable working pressure or pressure rating for the piping. Alloy piping material is typically specified as a thinner wall due to the added cost and its corrosion resistance. When having to select a relatively high-priced alloy material, try to select one that can be assigned a 0 corrosion allowance. Doing so provides a high safety margin against a process or chemical with a high propensity to attack its host pipe and allows you to use thin wall pipe or tubing to keep the cost down in doing so. Selecting a heavier wall alloy pipe material is usually due to higher pressures. not to anticipated corrosion of the material. If the theoretical corrosion rate of a material requires a heavy wall pipe, it might be more beneficial to select a different alloy or maybe make the move to lined pipe or a non-metallic material. Allowance for stainless steels and alloys. Alloys are selected for use against aggressive fluids, but material cost becomes an issue when doing so. Material assessment is made on the basis of being able to select thin wall pipe or tube. Given that, corrosion allowance for alloys is assessed at 0 inches or 0.03 inches in many cases. This marks the end of this excerpt. For more information on the complete course, please contact us at courses@wmhuittco.com. In the subject line, enter Request Info on the Module 5 Piping Design course. Thanks for watching.